All right, for these notes, you're going to want to use either a piece of graph paper to take your notes on, because we will be graphing lines, or use a piece of loose leaf for the informational part and use graph paper for the graphing examples. It's your decision on that one, but the graphing does have to be done on graph paper because it does make it more precise, and in this lesson, preciseness is everything. All right, we are getting ready to start the chapter on solving systems of equations, and there are 3 methods you will have to know. The first method is known as the graphing method, and since we already know how to graph lines, right, it shouldn't be anything of a surprise to you. You just now have to take and do one more part to it. But before we go into the actual examples that go with graphing, there's some background I need to give you. Right, the first thing is to define what is a system of linear equations. We know linear is lines, so these will make nothing but lines, so that shouldn't be a surprise to you. Right, but it's the system of equations part that you haven't heard before. Okay, and what this is 2 or more equations in 2 variable form. It means they have an x and a y. Okay, so an example of what a linear system would be is formally it uses 1 brace, right, which is kind of different for us because we're used to doing 2, right, but it usually has 1 brace, and in that 1 brace it holds the equations together that make the system. So for this one example, the equations would be x plus 2y equals 5 and 2x minus 3y equals 3. So you're going to have 2 or more equations in one system. Okay, so this is known as a linear system. And that's what we'll be dealing with this entire unit. Okay, the next thing you need to know about is the answers to these things. So the solutions to a system. Okay, and the solution to a system is always going to be, except in special cases, of course, but it's typically going to be an ordered pair. So that means your answer will be written as parentheses around that order pair, and the x and y numbers will be filled in. That satisfies each equation in the system. Okay, so what that means is that the order pair that you say is the final answer must work in every equation in the problem, or it is technically not the answer that you want. Okay, if it doesn't work in one of them, it is not the correct one. All right, so the first thing we're going to do is decide if the given ordered pair is the solution. So our answers will be a yes or a no, all right? But it will be based on us testing out this ordered pair. So this is the way you would check your answers to these problems if you wanted to see if what you were doing was right and you didn't feel comfortable with the work that you had going on. All right, so what these are going to look like, you're going to have a system of equations. Right, and sometimes it'll have that brace and sometimes it won't. Just know that formally it is supposed to be there, but if it's not there, it's not the end of the world. Okay, so here are your 2 equations for this system. And because we are trying to decide if the given ordered pair is right or not, I have to give you an ordered pair. So the ordered pair I'm going to give you is 5, 2. So our job is to see, is 5, 2 the answer to this system? And the way we do that is by plugging it into both equations and testing it out. Right? You have to plug it into both. All right, unless a special case occurs, and I'll talk to those about you as soon as we get through. So you know your 5 is your x and your 2 is your y. So plug those into the right letter spot for each equation. All right, so in the first equation, that means I've got 3 times 5 minus 2 times 2 equals 11. You're trying to prove and see if the left side makes 11 like the right side has. If it does, you get to say yes to that one. If it doesn't, you say no. All right, so we do our order of operations. 3 times 5 is 15. 2 times 2 is 4. When you subtract 15 minus 4, you do get 11. So for this first equation, it worked. Now, that doesn't mean it works for everything. You have to test them both out. If the first one you get is a yes, you have to check the second one. If the first one you get is a no, you don't have to check the next one because it's automatically not going to work. So now we have to go to the second equation and plug our numbers in. So negative 5 plus 6 times 2 equals 7. Okay, and again, do your order of operations. So 6 times 2 is going to be 12. and negative 5 plus 12 is 7. So notice that it worked in both equations. When both equations it works in, then your final answer is yes, it is a solution. And you can just write the word yes, but I wanted to make you understand and help you understand that that's what you're checking for. It has to work in both equations. Otherwise, it is not going to work as an answer. So let's take a look at another one. Just want to give you a couple of varieties so that you understand what's going on, because we'll be doing this more in class and through warm-ups and things as well. All right, so the next system I'm giving you is negative x plus y equals negative 2, and 2x plus y equals 10. And the order pair that we're checking is negative 4, negative 2. All right, so now we're going to take our x and our y and plug them into the first equation and see what happens. So when I plug in negative 4 behind the negative sign already, it looks like this, negative negative 4, which we know will turn into a positive here in a moment, plus negative 2, which we'll clean that up too, equals negative 2. All right, so let's go ahead and get rid of those double signs because that's going to mess you up if you leave them in there. Instead of negative and negative 4, it'll be positive 4. Instead of plus minus 2, it'll be minus 2 equals negative 2. 4 minus 2 is positive 2. 2 equals negative 2 is a false statement. That does not work. You don't even need to check the second equation. If it did not work in the first one, it cannot be the right order pair because the answer has to work in all equations. So immediately we can say, no, it is not a solution. Okay, so this part is all about plugging in and testing it in all equations, which is easy to do. Most of you will be very competent with that and you'll feel good about doing that. All right, it's the next part that we're going to have to make sure we slow down and understand the pieces of what we're doing. All right, this is known as the graphing method. So what I'm going to do when I teach you a new method, right, is that I will give you the steps for those methods and then we will practice some examples. All right, so before we switch over to graph paper, or if you're already on graph paper, that's okay. The steps for the graphing method is what I want to have you write down now, and then we'll practice a couple of examples that deal with that to see if you're catching on. All right, so the first step you're going to have to do is to write each equation in intercept form. And then I'm going to put in parentheses if needed. Sometimes your equations are already going to be ready, so you don't have to worry about that. But if they're not in intercept form, you must do that first. Okay, so then the second part is you are going to graph both lines in the same coordinate plane. That means two lines will appear in that same graph. Okay, so that's where our graphing skills get to come in useful again. All right, and if you use a straight edge, it does make them more precise and it does make it easier to see the answer as well. All right, step 3, you are going to determine the point of intersection. Right, and that means where the two lines cross. Your answer to these graphs will be the ordered pair where those two lines cross. If your two lines don't cross, you know you've done something wrong for right now. Okay, so they must cross in this method for you to be okay. All right, so check your graphing if that doesn't happen. After you determine that point of intersection, step 4 is optional. All right, and some of you will want to do it, and others of you will not. All right, but if you have that ordered pair and you have the original equations, you can check your answer algebraically. And what that means is that you check your answer just like we did above. You plug it in, and it has to work in both equations, or that is not a valid answer. Okay? All right, so for the next couple of examples, we're going to do 3 of them total. I will be switching back and forth between this screen and an actual piece of graph paper so you can see the pictures and how precise they need to be. But I will put all of the work and problems on this side and then just the graphs on the screen with the graph paper. All right, the directions are going to say graph and check the solution. And remember that checking part is completely optional. So I may only check the first one and then not check the others, but you can check anything you want to because you have that power to. All right, so the first example that I'm going to do in terms of the graphing method will be the system x plus y equals negative 2 and 2x minus 3y equals negative 9. What we're looking for when we're done is the ordered pair of where those two lines cross, right? But in order to make that happen, we've got to get them to the point where we can graph them, because that's how we're going to solve them. Right, so the very first step says to put them in slope-intercept form. So I'm going to have to take each one of them, because neither one of them are in that format already, and solve it so it says y equals mx plus b. All right, so in this first equation, I need to subtract the x over, and that gives me y equals negative x minus 2. That will be the first line that I'm graphing. Okay, then for the second equation, 2x minus 3y equals negative 9, I need to subtract 2x. That gives me negative 3y equals negative 2x minus 9. Be careful, there's a lot of negatives right there. Divide everybody by negative 3, and you get y equals positive 2/3 x plus 3. Okay, so there's my two equations that I want to graph. So now I'm going to go to my graph paper. And before you go and use that graph paper, you might want to identify your m and b if that helps you out. The m in this first one is negative 1, the b is negative 2. Okay, because that does help us graph. And then the second one, the m is positive 2/3, and the b is positive 3. Right. So we're going to take and switch to the graph paper and take a look at what these two lines look like so we can come up with that ordered pair. All right, so for the first one, we said that our m was negative 1 and our b was negative 2. So we're going to start at negative 2 on your y-axis. Remember, you always begin at the b. And because the slope was negative 1, we do have to make it a fraction. So negative 1 over 1 is your rise over run, which means from that starting dot, you're going to go down 1 and right 1, down 1 and right 1. Or you can go up 1 and left 1. The more dots you have on this line, the easier it is to connect your straight edge and the more accurate your picture is going to be. All right, so just keep that in mind that you don't have to have just 3 dots anymore. You can put 4, 5, 6, 7 dots, whatever makes your line come through more perfect. Okay, because accuracy is everything in this specific method. All right, so you want to draw your line. There's the first one. Now for the second equation, the y-intercept was positive 3. So up here at positive 3 on the y-axis, I'm going to put my point. And the slope was positive 2/3, which means up 2 and right 3. Now keep in mind, if I want to get to a point where these two lines are going to cross, if I keep going up 2 and right 3, I'm not going to see that. But if I do the reverse and go down 2 and left 3, you're going to see very quickly exactly where these two lines are going to be crossing. Right? And you can actually see it before you even draw your line. Okay, but draw your lines because you must have a picture that has two lines that are crossing. Right, so there's the picture to this. Now that's not the answer. The answer is where the two intersect, where they cross, which is this point right here. And you have to write it as an ordered pair. So for us, that's negative 3, positive 1. So when we go back to where we had our parentheses, we would put negative 3, 1. Okay, and we can check this. If you plug negative 3 into the top one, negative 3 plus 1 is negative 2, so it works. If you plug negative 3, 1 into the second one, 2 times negative 3 is negative 6. Negative 3 times 1 is minus 3. Negative 6 minus 3 is negative 9. Right? So it does check into both of them. So that makes you understand and know that you have the right ordered pair. Okay? If that didn't work, then that would be a red flag that your graph or your answer is wrong. Okay? So you have that ability to check it out. All right, for the next one, right, it's a lot shorter of a system. And it's a lot simpler of a graph as well. These are still two lines, and that's a system. Okay, so we have y equals 5 and x equals negative 2. If you remember your Hoy and Bucks symbols and silly sayings and how it works for you, this is going to be an easy problem for you. All right, because the first one was y equals 5, all right, that means it is a horizontal line through the 5, so you go up to 5. You don't even need extra dots. You're just going to draw your horizontal line across. Okay. And then for the x equals negative 2, that's a vertical line through negative 2 on the x-axis. So that would be this guy right here. Okay. And then the point of intersection is what you're looking for, which is this one point where they cross right there. And if you notice, that is the order pair negative 2, positive 5. So there is no calculation in this one. It's all done through the picture. Okay. And if you look at your system, look at what it says. It says the x value has to be -2, the y value has to be +5. If you look at our ordered pair, it works. Okay, so that's the easiest one you'll run into. You don't see a whole lot of them, but when you do, enjoy those because they do get a little harder. All right, this last one that I'm going to work out with you, all right, is going to be the hardest one of all that you would ever have to deal with. All right, but I'm going to show you how to get through it. All right, so the original system is 3/4 x minus 1/4 y equals -1/2, and 1/4 x minus 3/4 y equals 3/2. All right, now before you start panicking and going, oh my gosh, this is going to be super hard because it's got all these fractions in it, we're going to do something to make your life a whole lot easier. All right, this whole system has nothing but fractions in it. So we're going to take and we're going to make this whole system fraction free. And you know how to get rid of fractions at this point. So if the denominators are 4s and 2s, then you have to multiply everything by 4. So we're going to multiply everything in this system by 4 and come up with a new system that will still be the same picture and give us the same answer, but it doesn't look as confusing or bad because it doesn't have all those fractions in it. All right, so when we go ahead and multiply by 4, we end up with 3x minus y equals half of 4 is 2, so that'd be -2. Okay, that's the first one. For the second one, you would end up with x minus 3y equals 2 goes into 4 twice, so 2 times 3 would be 6. All right, and that comes off of multiplying by 4, which we've been doing that for a while in terms of getting rid of fractions. Now you're ready to proceed with the original steps. The steps first are to get them in intercept form. All right, so for each one, we need to make that happen. This first one, you're going to subtract 3x. So you have -y equals -3x minus 2. Divide everybody by -1 to get rid of that negative sign. And the first line we're going to graph is y equals positive 3x plus 2. So the equation doesn't look so bad now that you got rid of those fractions. Okay, over on the second equation, you're going to subtract your x from both sides. So you have -3y equals -x plus 6. You're going to divide by -3. Right, and that will leave us with y equals positive 1/3 x minus 2. Okay, so those are the two lines we're going to be graphing. And if you want to write your information down, you have m equals 3 and b equals 2 on this first one. And you have m equals 1/3 and b equals -2 on the second one. If you don't need to write those pieces down, then you don't have to. Right? But if you feel like that's helpful to you, then go ahead and write them down so that you can get your pictures right. All right, so then the last thing we want to do, well, before I switch screens, remember that we're looking for a final ordered pair where these two lines are going to cross. So we want to be able to fill that in by the time our graph is done. Okay, so what we want to do is now take a graph that is set up and go through and make the pictures happen. All right, so for the first equation, we were starting at +2. That's our y-intercept. And the slope was 3, so that means 3/1. So it's up 3 and right 1. Right? Or you can go down 3 and left 1. Okay, and then take your straight edge and make the line happen. Okay, your straight edges are super important because, as you notice as I'm freehanding this, as I can't use a straight edge, you don't get as accurate of a picture. All right, for the second line, it has to go through -2 on the y-axis, so there's that point. And our slope is positive 1/3, which means up 1 and right 3, or we want to go down 1 and left 3. Okay, and then you can connect those. Now, you're going to notice in this one that the point of intersection is not at a pretty little corner of the graph paper. That's okay. Right? So what we're looking for at our point of intersection right now is this piece right here in the middle of this box. Right? And what that means is that in your ordered pair, you will have 0.5s in there. And this is a time that decimals are okay. The only decimal you will give me in an ordered pair like this is going to be a 0.5. Okay, so don't try and give me any other weird kind of decimals. So if we're looking at this, we're going over in between -1 and -2, which is right here. That's -1.5. And then we're going to be between -2 and -3 right here, which is -2.5. So the ordered pair that we're getting is going to be -1.5 and -2.5. Okay, so every now and then the graphs of the lines will not meet at a perfect little corner on your graph paper, and you will have to have 0.5s in there. Don't be afraid of those. You don't see a whole lot of them, but every now and then one will show up. So just recognize that they can happen, right? And just be ready to read it as is. All right, so you're going to use these notes to help you. We'll practice more with this method in class. Right? It uses things that you've already known about graphing method, or about graphing in general, to help you get to the ordered pair that we now need to answer for these types of problems. Right? So hopefully that's just the newest part for you.